Hello my dear students, welcome to this online video lecture on fluid mechanics. So in the previous video we have discussed on stream function and its properties and its related equation. Then along with that we have also discussed a streamline and equipotential line, flow net and relation between the velocity potential and stream function. Now today in this video we are going to solve some of the numericals which have appeared in the university examination on this both velocity potential function as well as stream function. The question is, so the velocity component in a flow are given by u is equals to 6y and v is equals to minus 6x. Find whether the flow is possible or not and stream function. And this question is asked for 8 marks in the previous examination. Now, so in this numerical, I need to first I need to prove whether this flow is possible or not. So then again I need to identify the stream function psi. So as it is given, so let us solve this one. So as it is given, u is equals to 6y and v is equals to minus 6x. Okay. Now, so for a continuity equation, we know that dou u by dou x plus dou v by dou y will be 0. So let us partial differentiate this u term with respect to x and v term with respect to y. So if I partial differentiate this dou u by dou x, so then this term will become 0 as there is no x term here. And similarly, dou v by dou y term will also become 0 as there is no y term here. So if I substitute in this continuity equation, it will be 0 plus 0, so that will be nothing but 0. So then the flow is possible as it satisfies the continuity equation. As it satisfies the continuity equation, the flow is possible. Okay, the next is to identify the stream function. Okay, next I need to identify the stream function. So I will erase this thing. Okay, next I need to identify the stream function. As per the definition of stream function, so we know that dou psi by dou x is v and dou psi by dou y is minus u. Okay, minus u. So we know that we have already get v. So v is, so I will write it, dou psi by dou x equals to v. V value is minus 6x. Next, here dou psi by dou y is equals to minus u and u value is 6y. So sorry, 6y. So it will be minus 6y. Okay. Now we have got dou psi by dou x value and similarly dou y by dou y. So this is from the definition of velocity stream function. Now let us take this one term. So dou psi is equals to minus 6x into dx. Dou psi is equals to minus 6x into dx. If I integrate this term on both sides, if I integrate this one, so that is dou psi equals to minus 6x integration of dx. So it will be psi is equals to minus 6x square by 2 plus constant term. Okay, if I integrate on both sides, I will get this thing. Now it is nothing but psi is equals to minus 3x square plus c, minus 3x square plus c. So c cannot be the function of x. So this c will be written as function of y. So I will write this equation here. Psi is equals to minus 3x square plus function of y. So this c cannot be the function of x. So it will be written in the terms of function of y. Now if I differentiate this term with respect to y, if I partial differentiate this term with respect to y, so I will get dou psi by dou y is equals to 0 plus f dash y. But I have the value of dou psi by dou y. So dou psi by dou y is equals to minus 6xy minus 6xy. So I will write it here. It is minus 6y is equals to 0 plus function of y. Okay, minus function of y. So it is nothing but, so I'll directly get f dash y will be equals to minus 6y. Now if I substitute this value, this f dash value, so then I will get, so if I integrate this function, if I integrate on this function, so I will get it as f dash y. So that is fy will be equals to, with respect to y, if I integrate it, so it will be 3y square minus 2. Again it will be equals to 3y square. So minus 3y square plus some constant. Now substituting this f of y, fy function in the equation here, psi function, so that is psi is equals to minus 3x square plus fy is there. So fy we have identified. By integrating this term, we will get a fy term, that is minus 3y square plus c dash. Now substituting this y here, psi is equals to minus 3x square minus 3y square plus constant. So this is our streamline function, that is this is our streamline function. Now if you till this much, if you solve this, you will get complete 8 marks. So this question is asked couple of times in a VTU examination. Okay, the next numerical is the velocity component function pi is given by pi is equals to minus xy cube by 3 minus x square plus x cube y divided by 3 plus y square. Calculate the velocity in x and y direction and check for Laplace equation. Okay, so in this numerical I need to solve both. I need to identify the velocity, that is u and v, in x and y direction. Similarly, along with that, I need to check for a Laplace equation. So the given function is pi is equals to minus x y cube by 3 minus x square plus x cube y by 3 plus y square. So this is a velocity potential function given. Okay, now so as for the definition of velocity potential function, we know that dou pi by dou x is equals to minus u, and similarly dou pi by dou y will be equals to v. So this is a definition of velocity potential function, minus u and minus v. Okay, so these are the as per the definition we have written. Now u term, it is nothing but differentiating dou pi, that is pi equation with respect to x. So now that I will differentiate that equation. So here it will be minus y cube by 3, next minus 2x, then if I partial differentiate here, it will be 3x square y by 3 plus 0. Okay, this is a equation. Before that I will erase this one so that it will not be confusing for it. Now dou pi by dou x equals to minus u, so it is nothing but I will write this minus y cube by 3 minus 2x plus this y and this y will get cancelled, so it will be x square y. Okay, this is our dou pi by dou x. Similarly, dou pi by dou y is equals to minus v. Now in partially differentiating this pi equation with respect to y. So now it will be minus x into 3y square by 3 minus 0, as there is no y term, then plus x cube by 3 plus 2y. Now this, simplifying this equation, so I will get it minus v is equals to, these 3 get cancels, minus xy square plus x cube by 3 plus 2y. So these are the pi equation. Now the so this is not our answer for velocity. So velocity in x direction is u, velocity in y direction is v. Now here it is minus u is there. So if I multiply minus 1 on both sides, so you will get u is equation. So u equation will be equals to, minus into minus, it will be y cube by 3, then plus 2x minus x square y. So this is a velocity in x direction. Now similarly, the v component, that is velocity in y direction, it is minus, I need to get v value. So again I will multiply minus 1 on both sides. So I will get it x y square minus x cube by 3 minus 2y. So now this is a velocity in y direction. Okay, so if you write only this much, u equals to minus u equals to, so that is the wrong answer. You need to get u in a positive value, so that u will be equals to this. So this u is a velocity in a x direction, v is a velocity in a y direction. So the next step, so here is a half of the problem is solved. The next step is to check for the Laplace equation. Okay, now this question is for 7 to 8 marks, so half of the marks will be distributed for this identification of these velocities. Now what the Laplace, when you check for Laplace equation, remaining half marks will be allotted for that steps. Now for a velocity potential function, the Laplace equation will be dou square pi divided by dou x square plus dou square pi divided by dou y square will be equals to 0. Now this is a Laplace equation for potential function. Now we have dou psi by, that is dou pi by dou x, we are having, that is minus y cube by 3 minus 2x plus x square y. So this was a very heavy. Then again differentiating this term, so that is dou pi by dou x. Again we are differentiating with respect to x, so it will be 0 minus 2 plus 2x y. Okay, so now we have got a dou square pi divided by dou x square. This similarly we have dou pi by dou x equation, that is minus x y square plus x cube by 3, then again plus 2y. So again we differentiate this term y square. So that differentiating that equation with respect to y. So differentiating that with respect to y, I will get it minus 2xy plus 0 plus 2. Okay, so that will be equals to minus 2xy plus 2. So here it will be equals to minus 2 plus 2xy. Now if I substitute these two equations in the Laplace equation, so that will be equals to dou square pi divided by dou x square plus dou square pi divided by dou y square will be equals to 0. So we have identified the dou square pi divided by dou x square, so that is this equation, and dou square pi divided by dou y square is this. If I substitute both equations, so it will be minus 2 plus 2xy, again it is minus, is there, 2xy plus 2. So everything will get cancelled, so it will be equals to 0. Now this component satisfy the Laplace equation. So this, so it is satisfy, the Laplace equation is satisfied. So this potential function pi represents the possible case of flow. If you solve this much completely, 8 to 6 marks or 8 to 10 marks will be allotted for your solution. If you solve so these velocity component, half of the marks will be given. Then if you prove or if you check for the Laplace equation, so then you'll get complete marks. So let us see this one. If the velocity potential function pi, that is pi equals to n bracket x square minus y square, where n is a numerical constant, determine stream function and show that the flow is possible and irrotational. Now this is a question, and this question is asked for 8 to 10 marks in the university examination. Let us start the solution for this given numerical. Okay, now the velocity potential, it is given, already it is given. So it is n equals to n pi equals to n into x square minus y square. Okay, now as per the definition of velocity potential function, so we know that dou pi by dou x will be equals to minus u, and similarly dou pi by dou y will be equals to minus v. Okay, this is as per the definition of velocity potential function. Now if I partial differentiate with respect to pi x and similarly pi with respect to y, so I will get it n into 2x, and I differentiate with respect to x. Similarly, if I partial differentiate the pi equation with respect to y, so then it will be minus n into 2y. Okay, now by comparing this equation, I got u is equals to and v equals to. By comparing this equation, I can write u is equals to minus 2nx, yes or no? And similarly here v will be equals to 2ny. Okay, now I got u and v components. So now I got v component as well as u component. Now if I want to know whether this flow is possible or not, so then this equation must satisfy the continuity equation. So we know that the continuity equation for two-dimensional is given by du by dx plus dou u by dou y, dou v by dou y is equals to 0. Now this is a continuity equation for two-dimensional flow. Now we have value of u and v, so let us partial differentiate this u and v value with respect to x. Now if I get dou u by dou x will be equals to, it is nothing but minus 2n. Similarly dou v by dou y will be equals to 2n. Now substituting this dou u by dou x and similarly dou v by dou y in continuity equation, so we get minus 2n, it will be plus 2n, dou v by dou n is a 2n, so it will be equals to 0. Now this shows that the flow is possible as it satisfies the continuity equation, that is dou u by dou x of this potential velocity potential function is equals to 0, so then this flow is possible. Now we have done this one, so among this we have proved that the flow is possible. Now we have calculated the flow is possible. The next step is to know whether this flow is rotational or irrotational. For that we have Wz is equals to half dou v by dou x minus dou u by dou y. So this is a velocity potential function when I have u and v component with respect to z. Next, let us differentiate these with respect to dou v with dou x and dou u component with respect to dy. So dou v by dou x, if I partial differentiate this v equation, since there is no x component, it will be 0. Similarly dou u by dou y, as there is no y term here, so it will be 0. Now if I substitute these value in the rotational function, that is Wz is equals to half dou v by dou x value is 0 minus again dou u by dou y is 0, so it will be equals to 0. Now Wz is equals to 0 means the flow is irrotational. So the flow is rotational, and here it satisfy the flow is possible. The flow is possible. So now we have proved this second term, second identified. As we have to determine both flow is possible and irrotational, so that we have done here. So if you solve this much, so you will get around 5 to 6 marks for this one. Now the main thing is to identification of stream function, that is psi. Okay, let us solve that steps. So I will erase this one. I guess you have followed these steps. Okay, let us erase this one. So now we have already identified the flow is possible and it is irrotational. So next thing is to identify the stream function. Okay, so let us start for the identification of stream function psi. So for a stream function, it is for a definition of stream function, we know that dou psi by dou x is equals to v, and v we have already calculated in the previous step, so it is nothing but 2ny. Similarly, dou psi by dou, so I will write it here. Similarly, dou psi by dou y is equals to u, so minus u, it is minus u, and that we have already calculated in a previous step. Okay, now so as we know that I need to identify the psi function, so let us interchange this equation, that is 2ny into dou x. Similarly here it will be dou psi will be equals to 2nx into dou y. Okay, dou y. So I will consider this only one equation. I will go for, if I solve simultaneously it will be a confuse, so I will solve only one equation. Now integrating this equation on both sides, now integrating this equation on both sides, 2ny into dou x, so it will be psi is equals to 2nyx plus some constant value. Okay, so it is 2nyx into plus some constant value. So by integrating on both sides we get this equation. But we all know that this constant cannot be the function of x, so it is a function of y. So I will write this psi is equals to 2nyx plus c is replaced by the function of f, so I will write it function of f, function of y, sorry, function of y. So now if I differentiate, we got this equation. Now if I differentiate this equation with respect to y, if I partially differentiate this with respect to y, so I will get dou pi by dou y will be equals to 2nx plus f dash y. Okay, I will get, if I differentiate this one, I will get this term. But we already know that dou psi by dou y is equals to 2nx, so I will write it. So we already know dou psi by dou y equals to 2nx, so right, 2nx will be equals to 2nx plus f dash y. Now it will be f dash y will be equals to 0. So f dash y is equals to 0, it nothing means, so this f function of y is a constant, so it is constant. Now substituting this, or it is f dash will be also 0. Now substituting this in equation here, so I will get substituting this value, that is fcy is equals to 0. So if I substitute, it will be fy will be also equals to 0. If I substitute here, so the psi function will be 2nxy, as f of y will be, f of y becomes 0. So this is our psi function for the velocity potential. Okay, once again I will repeat it. So in the previous step we have already calculated the flow is we have proved the continuity equation, and again we have simplified for a rotational flow. whether the flow is rotational or irrotational, that we have identified. But the main thing is to identify the stream function, so this will carry a more marks weightage. So for that one, we have from the definition of stream function, we know that dou psi by dou x is equals to v and dou psi by dou y equals to minus u. Now again we have, if I differentiate with respect to v and u, these value are already calculated in the previous step. Now by integrating that equation, we will get one function, that is psi is equals to 2nyx plus constant. So this constant term cannot be as a function of x term, so it will be the function of y. So we have written psi is equals to 2nyx plus fy. Again, if I differentiate this equation with respect to y, we get equation 2nx plus f dash y. Okay. Then we already know that dou psi by dou y is equals to minus u, that is nothing but 2nx. So substituting that equation here, so I will get it phi f dash y will equals to 0. It is nothing but f of phi, that is a function of y, is a 0. So substituting that in this psi function, we will get psi is equals to 2nxy.